Okay, let's talk about the OScope. This video is really the first in understanding how to use an OScope. So we're only going to really focus on one channel. We're going to focus on this channel, this yellow channel, channel 1. Notice there's some human performance stuff. We've got a yellow band matching the yellow band here, which kind of matches the yellow number 1. So it helps you recognize that when you pick this up, you're on channel 1. And when we would use channel 2, again, similar band. We've got the blue matching up to the number 2, the second channel on the OScope. Well, I'm going to take this off right now just to get this out of the way a little bit. A couple other things. You have a bag, as you saw, with some of those bands that help different applications if you want to use the human factors associated with ensuring that the user knows what channel to get on. And then, of course, you have a little Allen wrench, a little screwdriver here, and you're going to see the purpose for that in a moment. So again, just like any other piece of test equipment, you need to understand how to use it. You need to understand the operational instructions, you need to understand the design, and you need to understand the applicability associated with the piece of test equipment, as we talked about before. Okay, and again, certainly before you connect your OScope, you want to visually inspect the leads. Notice this here is actually a ground connector from your lead off to ground, and then this is your positive side. You just pull this back and you'll get that little hook so you can hook it up into your circuits. You're going to find that, let me put this back on, channel 1, you're going to find that an OScope, unlike a digital voltmeter, only measures voltage to ground. So an OScope, you cannot measure across, let's say, a resistor and decide that there's a 5-volt drop on resistor 1 and a 4-volt drop on resistor 2 in series. You can't do that. You can only measure voltage to ground. But you can, in fact, get differences across a component. We're going to talk about that in the second video of the OScope. So again, we're only measuring voltage to ground by design on an OScope. And one of the first things you want to do, and you have a capability here where it's already permanently installed as a ground connector, and then you put your OScope on this this point right here. Notice we just went to a square wave. And that's how you would make adjustments and calibrating the probe. It's a good idea to do that, daily. You want to be on times 10, and I'll talk about that in a moment, but the probe should be on times 10. So you can, with a probe, you can have a times 10 or times 1. And that's not increasing the signal, it's actually attenuating it. Okay? I'm sorry. Yeah, in other words, your times 1 is you're seeing the output as it exists on the circuit. A times 10 is you're attenuating it by a factor of 10. So in many cases, when you're reading very small voltages, you may need to go from times 10 back to times 1 to increase the signal strength to the probe. And we'll talk more about that a little bit later. But anyway, so we're making adjustments. And the way you make the adjustment is, right now that actually looks good. You're looking at the rises and the falls of that square wave. So let me take it out of calibration. Okay, as I mentioned, you need to be on times 10 for when you're doing the adjustments. When you're doing the calibration, you need to be on times 10 on the probe. And in fact, anytime you make changes to that probe, you need to go into your channel. Like right now I'm in channel 1, and you come down here, see where it says probe 10 times the voltage. You need to make, if you have to make that adjustment, like now it's on 1 times and now it's 10 times. So you have to make sure those match up. But once they match up, you should be good. And notice the square wave is, it's not a clean square wave on top, and that's what you're adjusting. You want that probe to be adjusted so that it's a nice clean signal. Your rise and your falls are exactly parallel. And then there you go. So that's how you would make the probe adjustment. Okay? So then if I wanted to, I could put it back on times 1. Notice I made the change on the probe, The OScope, not realizing I made that change, shows the signal much stronger until I come over here to the probe and move that back to ×1. You want to hit this auto set, that'll make the adjustment, and your OScope is back in sync with the probe. Okay, so that's how you would make adjustments, okay? And that's, like I said, you want to do that maybe once a day. You got your little Allen or your little screwdriver, little Allen deal, and you'd make that adjustment. This should be in your bag with all your leads, okay? So that's what we'll do with that, and we'll put it over here. Now, to show you more about the OScope, I'm going to have the signal generated. Remember, we talked about that. Send a 1K signal over to the OScope. So I'm just going to make these connections, and you can see activities occurred. Now, what you want to do in all cases is anytime you make any major change, or what I mean by that is you take your probe and you put it on a new part of a circuit, you change the generator output, you want to hit this button over here called Auto Set. And that'll set the ranges, and it sets the inputs so that the OScope knows how to take that input signal and certainly display it correctly. So notice right now I've got that AC signal, sine wave coming in. If you remember, at the signal generator you can make adjustments in amplitude, so I can make those adjustments, and of course you can make changes in the frequency, and here you're seeing the frequency is actually changing on the OScope, but we'll leave it around 1K ohm. I mean 1000 hertz. So now, what do you want to do here? So you did the auto set. You always do that. And what you can do now is a couple of things. This is the vertical section of the OScope. You'll select your channels here, and there's a math function. We'll be talking about that in a little bit. And then this is the horizontal section right next to it. Then there's this triggering and a couple other different outputs. We won't be talking about that. We're only talking about the vertical, the horizontal for two channels, channel 1 and channel 2. You can select channel 1, and notice you get a whole bunch of stuff that'll come up. It says here coupling AC, coupling ground. Notice the signal went to ground. So that's kind of like saying, hey, what does ground look like? And then you can position. Notice I can position that signal, but I want that ground signal to be right at that crosshair, right in the center, and that would be positioned for moving the vertical. Okay. Couple DC. What that means is I showed you on the generator functionality that you can change the offset. So if there was a DC signal here with the offset, and in fact I could change it with the signal generator. Notice how I've moved that up. I'm putting DC on the line, and that coupling DC means it'll show both the AC and the DC. If you only want to see the AC signal, I'll couple it way up here. If you hit AC, your right center, it got rid of that DC signal. Okay? That's typically where we are when we're doing lab volt. And then there's other functionalities, volts per divisions course. I mentioned the probe. Then there's an invert. I can literally invert the signal, and we'll talk about that in a second video. So again, you can physically move the vertical line up and down using this vertical position. Okay, I had to go back because we didn't have the probes set correctly. So right now, when you're looking at the division, the scale for the vertical, which is really the magnitude, the division right now is 2 volts. And what that means is these large divisions, there's 2 volts in between. So notice if you go, I'm counting 1, 2, 3, 4 divisions, that means you've got 8 volts from the bottom to the top. So the peak to peak is about 8 volts, and in fact the OScope is saying it's about 7.6 volts. So you can change that scaling by making adjustments. Like right now the scaling is on 5 volts. So here you could see each one of those large divisions is 5 volts, and we're just a little less than that. We're about 8 volts. Okay. Notice here under channel 1, let's see, you can go over here to measure, and it gives you some some things that you can measure. So for example, the yellow is for channel 1, the blue is for channel 2. So we can select channel 1, and the source is channel 1. I could turn it off or I could put it back on. Okay? And then I can cycle through all the different things I want to measure. A lot of times you're going to be measuring the peak value, the frequency, or the peak to peak. Hit measure again, and let's put that measure again. Okay, so notice I'm measuring the frequency, and I could also measure channel 1. Let's measure peak to peak, and it'll give you the value right here in the square. But if I hit measure again, it will show you that, keep it here at peak to peak. So right now I'm measuring peak to peak, and I'm measuring frequency on channel 1. And again, if I want to change the frequency, I would use my signal generator and increase the frequency. So for example, I can go over here and start fine-tuning the frequency, and you're seeing it increase and decrease. Okay? So that's about measuring. I can select what it is that I want to measure. I can do auto range, and normally vertical and horizontal lines will be on the auto range if you want to keep it auto ranged, or you want to just make adjustments on the vertical range or the horizontal and so on. Now, this horizontal, notice I could change the position horizontal. Notice I'm moving left to right. And the scaling is all about the time it takes to complete that cycle. So right now, the frequent, or the division between each one of those big squares is 500 microseconds. I could change it. Now it's 250 microseconds. So I can reposition. If I want to line it, let's say line up, I want the sine wave to start right there, and I want it to end. I can read 1, 2, 3, about 3.5 of those large divisions. That's 250 microseconds. Each division would give me the period. The period is the time it takes to complete one cycle. So I can use that to determine the period and the frequency of the sine wave, all by making adjustments on the scaling. Okay? Again, you can move it left to right, purely not changing anything other than just physically moving it. Acquire up here on top, sometimes that's handy. The acquired, notice right now is set for sampling. The OScope is not doing this continuous monitoring and reading. It's actually sampling the signal. You can, if there's a lot of noise, that sampling may give you some erratic signals, so you can change it to show me, it'll just look at peak detections, or it'll do an average, or it'll do an average of like divided by 4. So it's a way to change the sampling periodicity of the signal. But most of the times you leave it on sample and you got good information. Got some other functionalities you can play with. I'm not going to show it on the video. And then this math function, you're going to see that, and you'll see the use of a second channel and why that's important. The next video, we're actually going to have it on LabVolt, and we're going to walk through a couple of the exercises in the first part of LabVolt to make sure everybody's on step with the OScope. Okay?